So we're going to continue looking at completing the square today. So yesterday we talked about how completing the square could be used for a lot of purposes, and we really just used it to solve equations. Completing the square is not the most efficient way to solve equations. I'm betting you'll never use it to solve an equation again unless it says you have to, you know what I mean? So there are not even any problems on my test that say you have to solve an equation by completing the square. That's just kind of like the first logical place to use it. Does that make sense? It's much more useful for things like converting between parabolic forms and also working with hyperbolas and other conic sections like circles and stuff like that. You have to use it on those. There is no alternative. Okay? So today we're going to use it to take, what form are these parabolas in right now? Can you guys remind me? They're in standard form. What's the other name for standard form? Polynomial form. They're polynomials right now. We're going to look at more polynomials next semester. Or maybe we'll get to it a little earlier. We'll see. But we want to take them and turn them into transformation form, because looking at them right now, it's hard to graph them. If they were only in transformation form, it'd be easy to graph them. So let's turn them into that. So I'm going to complete the square just like yesterday. So x squared plus 16x, these are not equations, right? Over here is a name tag, not a number. It's f of x. You need some room to complete the square, don't you? So I spread that out a little bit. And now you guys tell me, what's going to make this a nice parabola? What magic am I going to add here? You have an idea, Asha?
Isn't it 16 over 2 squared?
So what would that be? 64? Good. That's the magic. That's going to make this a nice parabola. Yesterday I got onto this analogy. I was thinking like Donkey and Shrek. That's a nice boulder. I don't know. Anyway, so I just put a magic red 64 there. I don't think you can just do that and have the same old F parabola, right? So like, how do you compensate? Well, there isn't another side this time, Bradley. A good idea. This isn't an equation. There's a name over there. You can't put stuff over there. It's a name tag.
But didn't you put parentheses around the x squared to the 64 and then add 64 as well?
Close, but if I add 64 again, then I'm adding even more stuff, and more magic stuff isn't going to help me get rid of magic stuff. Kyle?
You put it next to the f of x.
Yeah, that's what Bradley was saying, which was a good idea. But see, then you're gonna have to move it again afterwards.
Put parentheses over the from x squared to 64, and then you subtract 64 from 12.
There, Mary has a good idea. All those were good ideas. You guys all had some good ideas. This is really a clever zero now, isn't it? Because 64 minus 64 is 0. When we complete the square, we're actually adding a clever 0. There's multiplying by clever 1s, probably more important at lower levels of math. Adding clever zeros, the higher you go up in math, becomes more and more important. We do it a little bit in calculus here and there too. Yeah.
So is the point of this to get 3 zeros then?
Well, let's see what the point of it is. Maybe it's not clear yet,
Because
right?
it kind of seems pointless to add a 64 and then take it away.
It does. I agree with you, Kirsten.
Yeah. That does to make it
Kirsten.
more
I agree. She raises a good question. The reason we did that is because now, like Mary was saying, a couple of you guys were saying, Ella was saying it too, like you don't have to write that in parentheses, but if you want to think of it as that chunk is now perfect. It now factors perfectly as x plus 8, which is x plus 8 squared. That's why we put that red 64 there, so we could get that part to factor, and then this is just chump change left over. So what is it? It's negative 76?
8. Yes.
6, yeah, okay. And now look, polynomial form, transformation form. Now it's real easy to think about what this parabola looks like or draw a sketch of it. What's that do? Left, right, up, down, stretch, what?
It goes left 8,
Left 8,
down 76.
down 76. This is going to be hard to draw this guy. We'll just sketch it, right? So we'll say like this is negative 8. We'll pretend this is negative 76. Is this parabola opening up or down? It's opening up. Let's get its y-intercept on there for scale. Hard to do the y-intercept in transformation form. Easy to do it in the other form. It's going to be minus 12, so that should be like somewhere like right here, right? So there's our parabola. Yes, I know mine looks awful.
It looks like a snake.
But you guys get the point, right? Okay. Let's do one more of those. So now g of x. We already know its y-intercept is 3. But where is like the vertex? We're going to turn it into transformation form. So, here we go. Who can tell me the first thing I kind of need to do? We did one kind of like this yesterday. What's going to mess us up? So what do I do with that 2? Pull it out. You can't divide it because this is not an equation. It's still there. So here's what's left. Now I'm not going to try to pull it out of the 3. I'm just going to set the 3 off to the side. And now I'm going to add my magic. This time, what magic do we need to add? Here. 4. Negative 4 cut in half is negative 2, squared is 4. What did I really do when I put that red 4 there? I need a clever 0, yeah, but what clever 0? Because I didn't really just add 4 when I put that 4 there. This hits it, right? I really added 8. So to make this compensated for, balanced, I'm going to have to subtract 8. Okay, watch out for that. So now the reason we did that, what Miss Sarah was asking about a second ago, is because now this part becomes x minus 2. And we have some chump change out here. Now it's transformation form. So I could sketch this guy if I wanted to. You guys tell me, where's it been transformed? Right 2, down 5, stretched vertically by 2. So this is going to be right by 2, down by 5, still facing up a little bit steeper. How much steeper? Well, we can find the y-intercept. You can see that it's supposed to be a little bit steeper there, right? So, yes. A little better than that one, I think. All right, I'll see you next time.